in a thermodynamic system. It is. A gas undergo following process dq equal to 2 du plus dw. 3w. Okay, it's telling there is some thermodynamic system is there in which a gas undergo falling process dq equal to 2 du plus 3w. What do you mean by Gayatri? What is can this method be applied to any general process? What is the question first of all? I'm not getting. You can unmute and you can clarify your doubt. Yeah.
Sir, the before question, sir, can we apply to any general process, sir?
No, he has asked a question like where the pressure varies as a function of volume. He is asking you to derive molar capacity as a function of volume. What he has asked question, I think that we have to follow. No.
Okay, sir.
Hmm? See, one thing, don't generalize it. That's a major problem what everyone is having because we don't want to take risk. Means, what is the type of science we want? We want a science where what will happen? One formula for one chapter. That is not possible. Come out of this mindset. You'll enjoy the physics. Again and again, again and again, I'm telling this is for everyone, not for one specific. Don't come out of mindset. That's called a shell thinking because students want some sort of a at least 5-6 formulas so that they can solve any problem. There's no such thing. Every question open, let's think and do compare. Compare you when you compare different questions open, the difference will come. The difference will help you to analyze. There is a method. So what a student should do: learn, then compare, then have a conclusion, not a mere conclusion. Nothing wrong. You have to compare things, but you have to conclude. And don't expect that there'll be one formula. With that formula, you can solve any problem in a chapter. Not possible. If that is the case, then it would have been nicer. There's no need of coaching for you. Textbook would have printed that formula. You would have read, understood. Then you can solve any problem. Not possible. Okay, now is asking find the equation for the in a thermal system the gas undergo falling process. Find the okay. Let me clearly explain. What do you mean by equation for the process? Find or derive the relationship find all the parameters find how the parameters of gas are related. See, my replies are very harsh. Don't get hurt. Hmm? Because I want you to really, because if I just reply it very sweetly, pleasantly, you'll take it very lightly. That I think so. Definitely, if any of your father is an engineer, no, you ask your father how you'll behave. You have to behave a little bit some harsh way that one because then only things will get into picture. Not every time, but some core ideas. No, I should reply very strongly so that okay, sir, like a told like this, you'll be alert. That's the method. Huh? Okay, now he's asking. So all of a sudden, earlier some equations know something. So now he is bringing dq, du all, and he's asking how parameters of gas related. What do you mean by parameters? Very strange word. Anybody? Parameters, or if you want, you can write variables. There's another word you can write. What are variables of gas? Pressure, volume, temperature, because they are the things what happen which I can very easily know. So they're called variables here. So how pressure, volume, or pressure, temperature, or volume, temperature are related. Okay, let me start with the first question. Now, I think we had such a question. Okay, first, in the end, I'll comment it so that you'll understand the DQ. What is the first law of thermodynamics? Any process. So there's a given thing. Now, from first law of thermodynamics, dq equal to du plus dw. Okay, let me substitute this above here. So this will become du plus 2 dw 0 or dw. Oh, okay, no. Yeah. So du is equal. What is du equal to? In NCV delta T or NCV dt. In any process, what is dw? PdV. Okay, now let me use ideal gas equation. NCV dt to this will be NRTV. N get cancels, so dt by 2 R by CV dV by V. Okay, let's integrate this. Okay, there's limits. Let me put T1, T2. Okay, this 2R by CV. CV is let it be monoatomic gas or diatomic gas it be. So let me write in terms of that one only. So log of T2 by T1 V1. So this will be minus 2R by CV. Or this, if I rewrite, okay, fine. Huh? Let me take log on exponential on both sides. So eliminating that, T2 by T1 is equal to V1 by V2 R by 2R by CV. So T2 V2 2R by CV equal to T1 V1. So what is the generalized equation? What is R? CV R by gamma minus 1, we can write it as. R by gamma minus 1. So this will become TV 2. Okay, this is the equation. Huh? Are you getting? So this is the pressure. No, sir, I want temperature, pressure. You again use ideal gas equation, eliminate V. Anything you can bring it. So like this, the temperatures and volumes are related. I think you have come this question in on Sunday. You wrote this exam, no? Which is of this kind. Say this is the state of the teachers themselves. Some of the teachers they don't know like this question when to ask, where to ask. It came in advance. Am I right?
Yes, sir.
No, it came in advance. So we have a set of teachers where This question when to teach and when not to teach also we don't know, but they will teach. So what's happening here? In books questions are there, directly they'll just practice and they'll come and teach, finish over. So there's a major problem that is occurring in most of the third world countries. See, if you have a book and in the book solutions are there, this is what happens. So therefore a textbook should not have solutions. Very dangerous. If textbook is not having solutions, no, if a teacher also should prefer a book which will not have solution, then what happens? The teacher will think and come. If solutions are there, he will practice and come. This is what happening. So in most of the ITJ coaching, the 60% of teachers will be like that, where they just know question answers, no concept, nothing. And student also, if you learn just question answer, this is what happens. So when to ask this question itself, we don't know. It's something it's related to some general thermodynamic process, no, it is. And our syllabus is basic process. Okay, now are you getting this one? If they ask you like this also, don't get scared. The method is same. Huh? I'll give one more. Let's see that how you do this. Same sentence will be good.